This is CCS America series Let's Talk Lighting, where we go deep on machine vision lighting techniques and technology so you can solve lighting challenges more efficiently in-house. I'm Emily Ting, marketing specialist at CCS America and co-host of this series together with Lindsay Sullivan, our technical marketing manager, who is here to share all her knowledge and her expertise from her time as an applications engineer. Lindsay, how are you doing? Happy Friday to you.
Happy Friday. It's been a week. Automate is going to kill me one of these years. Maybe you too.
My superpower is that it kills me every year, but I am immortal, and so I just rise back up from the dead every time. I don't know if I'm
Feel like,
immortal or I'm a zombie. It's one of the two, but
or you're
uh,
like a cat and you have 9 lives and you can only work at CCS for 9 years before.
don't say that. A lot of people would freak out.
Oh, yeah. Me
maybe
included,
it,
actually.
maybe the secret is like inside I'm already dead, so like you can keep killing me and I just keep going.
Like the little Energizer bunny, but darker.
Yeah, the dark version of the Energizer bunny. I love it. That should be
Uh-huh.
my new, I don't know, logo. It's just I
Yeah.
don't know, a black bunny, a black zombie bunny.
ChatGPT could mock that up pretty well, I bet.
Enough about my alternative, personal branding, and let's get into talking about some lighting. And this month we are talking about line scan, which we talk about line scan cameras specifically, usually in machine vision, but it's more than just a different camera type. It's its whole entire vision system, and that will share, some technical principles with area scan applications, but it also has some unique requirements and considerations. And so today we're going to break it all down. We don't get them as much as area scan applications, but we do see them occasionally. So we thought we would dive into, all the specifics of line scan. And we'll just start with line scan. How is it different from area scan? This is actually so basic that I feel that me as a non-technical marketer can explain the really basic 101. Like even I can do it. So I don't know nothing after working for 6 years in this industry. Um, but anyways, in line scan, the way it works is the camera is capturing the image line by line to create the whole image, whereas in area scan, it's capturing the entire image in the field of view at once. So to borrow Lindsay's favorite analogy for this, it's like a loaf of bread. Line scan is like imaging each slice and putting all of those images together to get the whole loaf. And area scan would be, to image the entire loaf in one go. I've always been curious, Lindsay, where did you hear this analogy from? Because I hear you drop it in every training, and I have been meaning to ask you one day, what's the origin story? Is this, a Lindsay original trademark, or did you learn it from Leo or Keans, or where does it come from?
It would have been maybe Keans or I made it up. I don't remember.
You should say
I
it was
want to say I
yours.
made it up because, like, who's
Because
gonna fact
trademark,
check me? You know?
Lindsay Sullivan trademark,
Yeah.
intellectual property.
If I hear any of you talk about lion scan as a loaf of bread, I'm gonna sue. It's
Yes,
mine.
this was the real hard-hitting, machine vision lighting question: is where does the loaf of bread analogy come from?
Am I brilliant or do I steal other people's stuff? Question we'll never know.
Yeah, but that's kind of, the real basic 101. Is there anything you want to add to, my first explanation?
No, honestly, you nailed it. Nailed it on, the difference between them, taking one line at a time versus imaging the whole thing. We'll get into, pros and cons of it, but that's good basic.
All right. And then another part of the basic is like the encoder side of it. So do you also want to expand on that before we go into, talking about beyond the basics?
That's fair. Yeah. So the hard part with line scan, versus area scan is the movement has to be much more precise. With the area scan camera, You just have to make sure your exposure is fast enough that you can capture everything in the field of view. And like if there's a little bit of variation, usually it's not that critical. But with line scan, if you don't have your camera and your line rate set up to be the same like speed that your line, like your manufacturing line is moving, your images will get distorted. So if you like have it too fast, then your images really shrink and they get really skinny and like you can't tell. And if it's too slow, then it's really long. And so like you can very much tell if you're doing it wrong on line scan by how, if your image is like looks how it's supposed to or is distorted in some way. So
If you're getting like the fun house image effect.
yeah, yeah, yeah. And so it's like a fun. I remember it was always really hard when we would do line scan testing at Kientz to because you like bring in you have to like guess their line speed and you can like do calculations but it's not like perfect and unless you have an encoder because the encoder connects to the camera and like however the encoder spins it tells the camera like how fast to image so if it speeds up the camera just goes faster and they work together but if you don't have that and you're just like assuming it's a constant speed and calculating the line rate that's when you kind of struggle. So like encoders just kind of make it easier when you're doing line scan systems. But I just like remember the pain of testing line scan cameras on like lines that like okay let's try a line rate of this much okay maybe a little more a little less and just getting these terrible images till finally you kind of get close enough to test out your light.
Yeah, I feel like whenever we do get a line scan application to test, a lot of what I see Aredo spending his time on in our line scan lab, which we do have that in our Woburn, Massachusetts office. We have our own line scan lab. Hashtag ad. Not really. This is our own podcast video series. But anyways, yeah, he's spending a lot of time just trying to get that motion bit, the timing bit, you know, uh, where it needs to be. And I feel like that's where I see him spending most of his time. So
Yeah.
that's definitely one of the tricky bits of doing line scan is that motion.
Yeah, the reason well the reason why it's harder for him when he's doing it in lab is he has to like match their exposure time. Because if he just has it run, he can like actually line it up pretty simple, but he has to like adjust the speed to like match their exposure time to make sure that everything's, fitting with their line rate. So that adds another layer of complexity when you're doing testing too.
Yeah.
But yeah.
Yeah. So I don't know if our, first, what is it, 10 minutes, not even ish of conversation, maybe 5 minutes, has made this sound like really intimidating. Like, why would anyone choose the complexity of line scan over the quote unquote simplicity of area scan? So let's start by going into when should someone choose line scan over area scan?
Yeah, you're right. We did make it seem complicated. It is actually, it can make applications like significantly easier in a lot of ways, especially like moving webs. If you've got, like doing paper inspection or like, continuous plastic, stuff like that, having line scan is really good because you're not trying to like stitch multiple images together. You can just have it go and then stop and keep going right away and stop. So you can get much more continuous and better images. If your area is really wide, this kind of can go moving webs, if you have a really wide moving web, in order to get enough resolution on your camera, it just gets a little bit harder, so you get that. But even like general field of view, if you have a wide field of view, it can get harder with an area scan camera. A really high resolution line scan because what it is it's 8,000 like an 8K line scan camera is 8,000 pixels by 1 pixel versus like 5 megapixel cameras it's like a square 4,000 pixels by 5,000 pixels give or take whatever. And so you just have that one line but if you have 8,000 pixels by however many pixels you want versus like a set resolution that you would get with an area scan. So you can get much higher resolution images with just one camera that's even like kind of simpler to use as long as you get the timing better. So for those applications, it works really well.
I don't know if this is, again, where I'm showing my lack of technical expertise. Here's where, I drop off. But I guess why not use a giant high resolution area scan camera? Is it expensive? Is it money?
Both. It can be more expensive, but you kind of get into the sensor on the camera has to be a lot bigger. Then you have to have a larger image circle, so your lens has to be a little bit different. The processing is a little bit more, and then sometimes you kind of have useless space. Like if you're not looking, because your image is going to get bigger in the same ratio. So if you make it wider, it's also going to get taller. If you don't necessarily need it to be taller, then you're kind of just wasting all of this imaging that you're taking pictures of. And then if you do need, you know, because you can have a really easily, you can easily get a 60 megapixel line scan image, but you can't necessarily get a 60 megapixel camera as much. So you can kind of get more with the line scan. But yeah, you do run into just having it be more expensive and just a bigger camera to have to do that with.
Potentially another really dumb question, but do 60 megapixel cameras exist or are we not there yet?
You know, they might by now. When I was at Keyence, we had a 21 megapixel camera, and I think they're at 25. I don't know. I haven't looked into a 60 megapixel camera. I know that 20 at least exists. It might.
Yeah, I remember last year, the year before, I was doing kind of an article in celebration of our 25th anniversary as a company for CCS America, and we did the whole angle of like looking back at machine vision over the last 25 years. And the intro I wrote for it had, you know, like when machine vision was 25 years ago, 2 megapixel cameras was considered, you know, great resolution or, you know, cutting edge technology. Or something like that, 2 or 5. And so how far we've come, I don't know if we've come so far that we've reached 60 yet, though. If that's on the,
I don't think we've
you know,
reached 60 yet.
yeah. Maybe it's in R&D in some super niche facility somewhere, not ready for commercial use yet.
Maybe
Maybe
they don't
we'll,
need it because you can just use a line scan camera.
exactly, exactly. You don't need to develop a science community. Don't waste your effort. We have a solution.
It's not broke, don't
you
fix it.
use your limited money on something more worth your time. All right. Since we've already started to talk about kind of some of the challenges of line scan, let's keep going with that. So, one challenge in particular, why do faster line rates require more light?
I will answer that. I'm going to interrupt because I forgot to say one other really good application for line scan is like unwinding cylinders. Like if you want to look at a label on a bottle, because it's curvature, you have to have like multiple cameras
Right.
versus you can have a line scan looking at one line and then just spin it 360 and you can just flatten the image and just get one long image of the label. That's a really nice line scan application. So that's one of the other options people use it for. Anyway, okay, back to your question of line rates. Why do they require more light? So that's essentially like your exposure time. So the same way in area scan, when we have shorter exposure times, we just have less time for light to get up into the sensor. If your line rate is faster, you just have less time for all that light to get up. So you just have to have a more intense light to keep up with the speed. So it's actually the same principle as the area scan cameras have in terms of speed and exposure time. But you do have to have, you only have an area scan, you've got, you know, lots of pixels, you know, 5 million pixels to interpret all of that versus in line scan, you've got 8,000. So you have fewer pixels interpreting said data. But you're also not imaging the whole thing. Like it's still just a line. So like it's similar, but um, just speed. Anyway.
Yeah. So how do you deal with the brightness fall off then if you have a wide field of view?
Yeah, this is essentially why you can't just stick a area scan light on a line scan camera, given it matches the field of view. A, none of them are really made that long, but B, the line scan lights are specifically made to be more uniform and to have the same amount of intensity at the edges. So you want to purchase a line scan light that's longer than the field of view that you have because the way the light's going to come out, you know, it's not going to be perfectly bright at the edges and be like a perfect rectangle. It's kind of It doesn't get a uniform intensity until 50 millimeters on either side of the light. So your light needs to be at least 100 millimeters longer than your field of view, so you don't have the drop off on the edges. And then all of the lights are designed to be uniform, and some are more uniform than others. If it's going to be used as a backlight, they're like super duper uniform, but they're less intense, but it's a backlight, so that's okay. Versus others are, you can get, it's kind of the same with like the EFFILUX. You kind of have a trade off of uniformity and intensity. So you can get like the LNSP2 standard, or like the NDF, which is no diffusion. And that one will be more intense, but you don't have like the uniformity. So it kind of depends on what your sample is. Is it reflective? Is it not? Um, is it like matte? Will it diffuse the light more? So to answer your question, when you're dealing with brightness and these long field of views and stuff like that, you have to have a designated line light. These line lights are designed to be uniform and intense and have, overlapping zones, and just make sure that you're getting a light that's long enough for your field of view.
Yeah, you mentioned long enough, and the I think thing I hear a lot when I'm, overhearing conversations about line scan applications or, even just a wide field of view is like, do you use one long light or do you use multiple smaller lights? How do you
Mm.
make that decision? So, what's your 2 cents on that?
Yeah, there's like a, if you're gonna like make a graph, there's like a point where like it's no longer a benefit to have such a long light because it's gonna cost so much to ship it. Especially if you get like the EFFILUX ones from France, like they're really nice light, but I mean even Japan too. Like once a light gets over a certain amount, which what is the amount? I'm gonna say it's like meter. I should know. I
Mm,
used to know off the top of my head how much like after it got over a certain amount, it was like too much to ship. But um, if you can make it one continuous light and it's like not a crazy amount to do it, that's always going to be the best because you won't have the kind of seams where the lights come together. But you can you know daisy chain or put like two lights together. And I know for EFFILUX they design the lights connector to be at the end, so you can put two of them together really easily, but you can't really put three together. But you can customize it and like move the connector if you need to put three or four of them together so they're all like butting up against each other. But you just want to make sure that you overlap the illumination zones so you don't have that drop off. You don't have like the
mm.
dark zones in the middle of the image, so you kind of have to overlap the lights a little. And it's easier in some ways to do it with the line scan because you only have to make like one pixel uniform versus area scan. You're
Yeah,
making a whole
yeah.
field of view uniform. Versus this one, you have a little bit more flexibility of illuminating the one pixel field of view. Um,
Yeah, are there any like tips and tricks to how do you overlap them? Is there like a formula you calculate or whatever?
I mean, it's about 50. You can look at a lot of the lights. Yeah, a lot of the lights will provide their like uniformity that they illuminate kind of thing. Like, it'll look
Mm-hmm.
like a line. So just make sure that, okay, it's at its flat uniformity within 50 millimeters or 75 millimeters from this side and 75 from this side. So just put those up to line them up. So formula wise, no. But looking at the uniformity data of the line light, you can kind of decide how much you'll have to overlap to get imaging. And then it's a little bit of trial and error, as all testing in machine vision is.
Yeah. So you said it's easier, or I don't know if it's, I guess, how would you consider the complexity? Because, like you said, it's just the uniformity for one line of pixels, essentially. So, in my head, that, sounds really easy. But machine vision is never that simple. And, from our conversation for the last couple of minutes, it does seem like, you know, it's unexpectedly hard to achieve uniformity in line scan applications.
Yeah, it's both. It's because it's easier in some where, like, you're right, you're only doing the one line of pixel. You're not trying to, like, if you need a dome light, for example, and it's a really big field of view, that would be a giant dome light that just, like, they don't really make. It would take up so much space.
We'd
No one
love
would
to
have
make
room
one,
for it.
maybe. I actually don't know about that. Money-wise, it sounds great, but even then, I'm not sure. Money-wise, it would be worth it.
They'd have to build a new mold for this one application to make this one giant dome light that's, whatever. They probably would, but they wouldn't, it wouldn't be worth it cost-wise, I'm sure. But like with a line scan light, you just have to have 50 or 100 millimeters and you're covered. It's quite long, however long your field of view is, but that's much more achievable than like having it be long but also circular. So it's easier in that regard where you don't have to have these giant lights taking up space. But designing lights, the longer the light gets, you've got electricity current running through. Sometimes like the middle might not be as intense as the edges, stuff like that. So the longer lights get, the harder it can be to kind of make sure they're uniform all the way across. And like, that's something that CCS knows, so they put in a lot of effort to make the uniform light so that it's not really like a U problem, it's a lighting CCS lighting design problem. But it is a problem that we have to solve as the line lights get longer. So it's harder for that. But I actually think in a lot of ways it can be easier to solve line scan lighting applications because you just have to make sure that one pixel is illuminated and you get a little bit more forgiveness, of than you do with area scan in a lot of ways.
Sure, yeah. Um, do you want to talk a bit about the how the lighting techniques differ between line scan to area scan? Because there's a lot more similarity than I think people give credit for as well.
Yeah, it's honestly it's pretty much the same because you can use polarization, you can use polarization, you can use bright field, dark field. It's just however you like orient the bar light straight up or off to the side. There's coaxial units that you can put on. We have don't line dome lights. There's not ring lights, but like you don't really need it because you're imaging for a line. So like it's
Yeah.
low, bright field or dark field, right? So
Yeah,
like
no need for ring
if it doesn't
lights.
exist, it's because it doesn't need to. Yeah.
Yeah.
So a lot of it really is the same, and a lot of the, are you looking for scratches? Do you need to raise your light in the coaxial up and down a little bit, or should it be closer? And have we used flat dome lights? I feel like we have used even the LFX-V in a line light before. I think we have. Yeah. So backlight is also a thing. Really, it overlaps in terms of the lighting principles I love to talk about all the time. Between line scan and area scan are very, very similar. The biggest difference is just how the light is designed to be more in line, ring light versus long bar light kind of thing. But principles are there. It's all light is the same.
Yeah. Is it, or so one of our unique line scan lighting selling points is the
Mm.
bidirectional oblique angle lights, and they're really unique and awesome. But do you want to talk more about the lighting, how our tried and true lighting principles, the physics of that works out? Because it's not like you're doing a dark field application, for example. It's probably closer to bright field. But yeah.
Yeah, that's a really good one. So okay, so pretty much when you have a ring light, you have light coming from a low angle. We'll say low angle ring light coming from a roll angle from all sides. And so you get it from north, south, east, and west all at the same time. When you're imaging a line scan light or line scan system, you take your line light and you put it, parallel with your web, for example. So like your web is this long, the light shining down on the light. But you essentially get north and south illumination, but you don't get the east and west illumination with line lights. And so if your defect, your scratch in this web is perpendicular to the way the web is moving, that light coming from an edge will highlight it and it will be super visible. It'll be really easy to see. But if your defect is in line with the web, it's, parallel to it, the way like, let's just imagine there's like a pin sitting down, and then as the web's moving underneath, it just gets this continuous long scratch. The light coming from the direction of the north and south isn't going to highlight that as much as light coming from the east and west would. So that's kind of where the ring light would be a benefit there in the area scan situation, but we're using a line scan situation. So what those oblique angle lights that you talked about do is they provide illumination from the side. So there's two of them. There's one where it's just from one side and you set it offset a little bit. So it's like your web is here, the light is lined up like to the side of the web shining down. So that's giving you a low angle from the east or west side, one or the other. And then there's the other one where it does both. It kind of like the light shines out. Is it mirrors? Gosh, but you talked about all of these in depth and how they were built. I think it's mirrors that they use to like reflect the light down off to the side. So it doesn't shine straight down, it shines down off to both sides. So you can get the east and the west low angle while it's sitting over your line scan system. So that's how you can get the defects that are appearing like in line with your web that are typically hard to get with line scan lights.
Okay. And again, dumb question here, but would you use an oblique angled light with your standard LNSP2 on one camera so that you're getting all directions, or would you want the oblique angled on one camera and then another stage where it has the LNSP2 during the north-south?
That is not a dumb question. That's a very good question. I have never always put them together.
I ask those kinds of questions.
Very good question. I would say that would probably be application dependent. My like instinct is to say they should be separate because the light would like kind of treat it more like a dome light. You'd have it coming from the north, south, east, and west, and then it would just be dome lighting and hiding it anyway. But like, if they're all low angle, maybe it wouldn't. I don't know. I've never tested it, and I kind of wish I had before.
I guess depending on the speed of the application, could you turn one of the lights on and take the picture of that, and then turn the other light on and take a picture of that? But it depends on how the thing is moving.
That's a good segue into talking about strobing in line scan, because most of the time line scan systems are continuous. They're continuous lighting. But every once in a while we do, because it's taking one line at a time and putting it all together. And so if you have any type of like if it's just not synchronized even the slightest bit, you can really see it in the image and it can cause a lot of problems. That's why we don't even use pulse width modulation, because the flickering can be so disruptive to getting a good image. But there are times and places for strobing it, and whether it's using multiple lights or something. Like I know Gardasoft did a full color line scan where they did a custom RGB line scan light, and then they could get a full color image with a black and white camera. And they were strobing that, and it worked well. You just really have to make sure the synchronization is there. So that would be honestly a great example. And I think that's what the like shape from shading line scan is too, that they do. It's pretty much that of taking north, south, east, and west separately, and then loading it all together. So long story short, yes, that is a good solution. It's not typically done in your standard line scan applications, but we do use strobing sometimes for that, or if we really have really high speeds and we need to use like a dedicated strobe type of light to get higher speeds.
Yeah, so from what I'm hearing, you would only use strobing if you're doing kind of a multi-light line scan situation, or if it's a really high speed line scan and you need to kind of boost the intensity on it.
Yeah, for the most part, yep.
Okay.
Like you can use a continuous light, so all of our like line lights are current driven. Yeah, if you guys know one, let us know. I haven't done a lot of line scan testing over the years, although I was the one who helped build that line scan lab. That was a Leo and me project. But yeah, it's Leo. I was gonna say something and I totally lost it. Leo made me sad and then I
Continuous
forgot.
lighting. Continuous lighting and current
Yes,
driven
okay, thank
line
you. Yeah.
lights. Yeah.
Yes, current lights don't use pulse width modulation. That's a voltage thing. So a lot of line lights are current driven, and they have like dedicated current controllers. So as much as CCS standard CCS lights are voltage driven with voltage controllers, line lights are gonna more likely be current driven.
Gotcha. Do you want to talk more about why they have to be designed like that? That's getting into the technical stuff, so I'm sure our audience would like it. It'll probably go over my head a little bit, but you're the expert and you explain things pretty well, so maybe I will get it.
Do you mean like why they're designed with current, or what do you mean?
Yeah, like why, or I guess how it works, and I guess, yeah, also why they have to be designed like that is, like, for example, you said earlier, it part of the challenge of especially larger line lights is to get light or electricity all the way to the center up, or across the whole light, especially when it's bigger. Is that why they have to be current driven, or is there some other technological reason?
Yeah. So a lot of when things like our voltage controllers, like the PD3, PD4, stuff like that, they use something called pulse width modulation, which pulse width modulation is essentially really high strobing at a frequency so fast that it looks continuous to us and like doesn't affect the image. So it's actually when you turn the light down 50%, the light is just flickering half the amount of time in the period. So 50% intensity is just the light flickering half the amount of time versus 100% it's just, not flickering at all really, but it's still flickering, which makes so much sense. But when you have the flickering continuously, even if it's at a frequency that looks continuous to us, that can still cause problems with the line scan light because you're taking just one image at a time and line after line. And so we don't want to use pulse width modulation or those voltage driven controllers. You could use like analog voltage controller, but current controller, I would say like pulse width modulation is good, but current is better than just like straight voltage in terms of like how you control things. So if you're not going to do pulse width modulation, then you would want to use a current driven controller. So since we don't want to do that, we step up to a current driven controller, which just gives you more, there's more benefits to a current driven controller about, being able to control, gosh, I wish Max was here. He'd tell us all about it. But like, you kind of like the heat can change over time, the color temperature can change over the time. That current controllers kind of just do better with. So we use that to make sure that there's no flickering in the image and it's just a continuous light output. So when the camera and the line scan camera is strobing, it's continuous intensity and there's no there's no missynchronization. It's perfectly synchronized across. You don't have to worry. I guess you don't have to worry about perfectly synchronizing the pulse width modulation with the line scan camera. It's just on how it's supposed to be on, and the camera can take pictures as needed. And then for the width of it, that's not a pulse width modulation thing. That's just like getting enough like current to run that long distance. So a lot of times in like longer lights, they'll put like cables throughout. So you have like 3 cables coming. So like the one cable doesn't have to send the current so far.
Yeah, is that how it is in voltage? And I guess that's why it's not as good to do a longer or larger voltage light. Is that how it works? Again, no electrical engineering background here.
Yeah, it's less that like you wouldn't do it in voltage because the voltage is going to act different. It's just more that if you're not doing pulse width modulation, you would want to use current over voltage. So like you would still, even if you were using a voltage light, you would still like if the light was long enough, you would still want to be able to like build it to make it uniform. Voltage or current, you would build it the same. It's just like the electronics in it of do you put a resistor, do you not put a resistor, that kind of stuff. And then you would ideally prefer current over voltage and if you're not doing pulse modulation. Does that make sense? I feel like I'm not explaining it super well, but
I can't tell if it's because I'm not an engineer and that's why it's going over my head or not. So hopefully our audience, gets it. If you don't, email us at marketing@ccsamerica.com and I don't know, send follow-up questions or I don't know, get mad at Lindsay for confusing you. File a complaint.
Fair.
Marketing at ccsamerica.com. Just one day we receive hate mail, start receiving hate mail.
It would be next level if I started getting it to my house. My work's like, why are you getting angry letters?
Somebody just starts throwing tomatoes. You walk out. One day there's tomatoes. Oh, hi, Ham. Aww.
Hi. Okay. I will say it's been a long time since I dealt with line scan systems and stuff. I did a whole training in Japan for 2 weeks and got really, really good at it. And then I came back and we had one line scan application and I lost all of it. And I was like, well, it was fun while it lasted.
Yeah. Anyways, I guess we'll move on then. And again, if you want to learn more about it, email Lindsay and she can, I don't know, dig up all that stuff she learned in Japan. It's probably somewhere in our server or in our SharePoint. All she has to do is look for it for 5 days and she'll eventually uncover it. All right. We'll close out then with maybe some troubleshooting and common mistakes. So what are some of the biggest things people underestimate or, get wrong about line scan systems?
Yeah, I would say synchronization can be the hardest part, and that's with the motion control, the encoder and stuff like that, getting that to line up and not stretch and, shrink and stuff like that. But also lighting wise, if you aren't using just a really, dedicated line light and you're doing any type of strobing, getting that synchronization in line too is going to be more difficult to kind of make right, I guess. But the good news is if you are getting a stretched out or a shrunken image, it's very clear what the problem is, that your encoder and your line rate isn't right. So you know exactly what to fix because it's very evident to make it fixable. But I would say that's probably the biggest thing that people underestimate is just getting the motion in line to go with the camera properly.
So if you're getting a distorted line scan image, first thing to troubleshoot is the encoder. What are some other, I guess, common examples of bad line scan images, and what's the first thing you would do to troubleshoot those different types of bad images?
Yeah. I mean, lighting can always be a thing too. That can, very much not understanding how intense the light has to be to meet your line rate, stuff like that. So doing testing before to make sure that the light you're getting is super intense, because we've got our standard line lights. The LNSP2 was 700,000 lux, give or take, but we have some that go well above 1,000,000 lux if you need that level of intensity. So making sure that you're getting a uniform light if you require the uniformity based on however your sample is, or the intense light, and just kind of the same as area scan lighting principles apply. It all comes from lighting, designing those systems that can fit your light and fit it where it needs to be, and the kind of light, the length of light it has to be, doing all that up front before, moving, locking in where you can't put the light where you want it, or can't fit the dome light that should solve the application. So doing the lighting testing first as well is also super critical. And if you're getting a bad image, that's always one thing to look at. Did you get a uniform enough light? Did you get a bright enough light? And that kind of stuff.
Yeah. Is there such thing as getting a blurry line scan image? Because, brightness would probably solve a line scan image that's too dark. I'm thinking again about area scan and the kind of common problems you see with images there, but I'm trying to think if there would be like such thing as a blurry line scan, because it's like, can you see blur on a saran wrap? I don't know, plastic wrap.
Yeah. You know, what you talk about vibration is kind of a tough thing in line scan because it moves, webs aren't, they're moving. So like they kind of move up and down a little bit more as they're being pulled and stretched. And so you have to make sure you have a good enough depth of field to keep it all in focus as it moves up and down in your, image. So that's a really, really great point, actually. Look at you, Emily, bringing up things even I didn't think of.
I feel like there's been highs and lows
I'm
in
asking
this
you the
questions.
episode. Yeah,
This
I wouldn't say I'm at my
episode has
best. I'm not
highs
gonna
and
lie. I had quite the morning.
No, I meant more for
Uh,
myself. There's been moments where it's like, oh, I feel like, oh, I might not know everything, but I'm really insightful. Like, that's good things. And then there's moments where it's just like the explanation is going way over my head. It's like, oh, I've been reminded of my place.
More
Don't
than
try to
likely, I
rise
just didn't
above
do
your
a very good
station.
job doing it.
No.
Stay in your lane, Emily.
Don't have dreams. Don't
Yeah,
aspire to greater heights.
don't work for us at CCS.
Uh, on
Our
that
values.
optimistic note, on that optimistic note about my optimistic future, we have
So I just
come
want
to
to
the.
say we started this saying that you're like a dark energizer bunny, and we ended it with you shouldn't have dreams.
We've come full circle in my internal pessimism.
Well,
Well, we need to inject some positivity back into this episode, or else we'll probably get into trouble. So let's talk about some exciting things coming up with CCS. In just a few weeks, we'll be at Automate in Chicago from June 22nd to 25th. Super exciting. We just shipped everything out yesterday. So all we have to do now is see what will go wrong. Again, sorry, bringing back the pessimism. I need to stop. We shouldn't have talked about trade shows. Uh, but we
we
did
are
give
excited
us.
to be at Automate for the record. It's gonna be fun, and like we are
It'll be
ready.
fun. It's just
Yeah.
stressful for a marketer who has to get everything prepped and make sure that it
Hmm.
gets there in time. And then for some reason, people come to us when things go wrong. And it's like,
That's why you're
just
here.
I'm just here to make sure that we have carpet padding and a hanging sign.
Like really stressed about that.
Yeah, we'll see.
Uh,
Yeah, everything that we're going to be showing at our booth in our last episode of Let's Talk Lighting. So you can go watch that on our YouTube channel. So yeah, come see us at booth 3409. Also, come see Lindsay on Wednesday, June 24th at 3:30, because she will be giving a presentation at Automate about high-speed applications. The title is Lighting at the Speed of Automation, Designing for 1,000 Frames per Second and Beyond. Great title, by the way, Lindsay. I am really looking forward to it. So I hope some of the audience will be able to attend that. But if for some reason you're not able to, whether it's because you're not at Automate or you don't have access to the speaking sessions, do not fear, because next month on Let's Talk Lighting, we are going to talk about high-speed applications. I'm sure we'll draw a lot from Lindsay's wonderful presentation, so you'll get the, free delayed version. It kind of reminds me of like, how these days a movie will come out in theaters and sometimes people would just rather wait the 3 weeks that it'll take before it ends up on some streaming platform that they already subscribe to.
it's so real. Yeah. And I also will talk about it at the Vision Spectra conference, the virtual one. I'll talk about it there too a little bit. So yeah, there's 3 ways to learn about high speed lighting.
It's a relevant topic as everybody just wants to produce more things faster. So it's super relevant to today. So definitely hope to, see you at the show, to our audience. It'll be a great time. And if you've learned something new about machine vision lighting today, please give this video a like and subscribe to our channel. You can also follow CCSA, Lindsay, and myself on LinkedIn. And feel free to send us your questions or topic ideas for this series, either on LinkedIn, or you can email us again at marketing@ccsamerica.com. We'd love to hear feedback so that we can create this series so that it gives value to you, our audience, and help you design more effective machine vision lighting systems. So once again, thanks for listening, and see you all soon at Automate.
Thanks, guys.